Intro, the stillness that holds everything. This perspective changes how we think about power. We are trained to notice explosions, motion, disruption. We equate force with visibility. But the universe disagrees. The forces that last are not those that flare brightly and disappear. They are the ones that persist, quietly doing their work over immense stretches of time. Gravity does not shout, it pulls, relentlessly, without pause. It shapes stars, planets, and galaxies without ever announcing its presence. Electromagnetic forces bind matter together, guiding electrons into stable patterns that make chemistry, biology, and life possible. Strong nuclear forces hold atomic nuclei intact, overcoming immense repulsion through perfect balance. None of these forces seek attention. None of them require noise. In nuclear physics, this lesson becomes unavoidable. Every calculation depends on precision. Every system depends on limits. A reactor does not function through excess. It functions through control. Energy is not unleashed indiscriminately. It is guided, moderated, contained. When discipline fails, consequences follow. When discipline holds, power becomes useful. This is why the study of such forces is not merely technical. It is philosophical. It teaches restraint. It teaches patience. It reminds us that understanding comes not from rushing forward, but from standing still long enough to see what is already there. Progress is not always acceleration. Sometimes it is alignment. Stillness in this sense is not the absence of motion. It is motion held in balance. It is tension that has found structure. It is energy that has learned where it belongs. And once that balance is understood, once the fundamentals are mastered, the same quiet forces that shape the universe become predictable, reliable, and profoundly powerful. Nothing about this process is dramatic, and that is precisely why it works. The universe does not impress us, it operates. And in learning to see power where nothing appears to be happening, we begin to understand how everything that exists continues to endure. Chapter 1. The nucleus, a lesson in concentration. Instability, in this context, is not failure. It is information. An unstable nucleus reveals how close matter exists to its limits. Radioactive decay is not an explosion of chaos, but a correction, a slow, lawful release of excess energy as the system seeks a new balance. Even decay follows rules. Even collapse is structured. When a nucleus changes, it does not do so arbitrarily. It emits particles, transforms identity, steps from one state to another through defined pathways. Each transition is predictable, governed by probabilities that emerge from deep symmetry rather than chance. What appears random is, in fact, constrained by mathematics so strict that deviation is impossible. This is why nuclear reactions can power cities or destroy them. The difference is not the force itself, but how precisely it is managed. Fission releases energy by dividing heavy nuclei along known fault lines. Fusion releases energy by forcing light nuclei together under extreme discipline. In both cases, the energy was always there. The reaction simply provided a path for its release. Control, then, becomes the central question. Not how much power exists, but how carefully it is handled. A reactor succeeds by preventing extremes. It slows neutrons. It absorbs excess. It maintains equilibrium moment by moment. Power is never allowed to surge freely. It is kept on a narrow course, constantly corrected. This mirrors a deeper pattern found throughout physics. Systems endure not because they are strong everywhere, but because they are balanced where it matters most. Strength concentrated without regulation becomes instability. Strength guided by limits becomes structure. The nucleus teaches this lesson without compromise. Its endurance is not proof of brute force, but of exact conditions held without deviation. And in learning to describe those conditions through equations, measurements, and careful repetition, physics reveals a broader truth, that the most reliable power in the universe is the power that remains controlled. Chapter 2. Stability is active, not passive. This requirement for continuous balance is why stability in nuclear systems is never permanent. It is conditional. It depends on energy levels, particle arrangements, and exact relationships that must be maintained without interruption. A stable nucleus is not one that has reached an endpoint, but one that remains within acceptable limits. Drift too far in either direction and stability dissolves into transition. This is why isotopes exist. Atoms of the same element can differ only slightly in neutron count, yet that small difference determines whether a nucleus persists for billions of years or decays in seconds. The distinction is not dramatic, but the consequence is absolute. Stability does not tolerate approximation. It exists only within narrow margins. When equilibrium fails, the resulting change is not chaotic. A nucleus does not collapse arbitrarily. It decays along permitted channels, emitting particles and energy in specific ways. Even transformation obeys conservation laws. Even loss is structured. The universe does not abandon order when balance is disturbed. It replaces one configuration with another that better satisfies its constraints. This reveals something fundamental. Stability is dynamic by necessity. It requires constant opposition, continuous correction, and exact conditions. The absence of visible motion does not indicate the absence of activity. It indicates that competing processes are perfectly matched. Nuclear physics therefore reframes how we understand endurance. Persistence is not a state achieved once and held forever. It is a condition maintained through uninterrupted regulation. Forces are always acting. Change is always possible. What endures does so because balance is actively preserved, moment by moment, without exception. In this sense, stability is not the quiet of rest, but the silence of forces that have been brought into alignment. Chapter 3. Energy was always there. In nuclear reactions, what changes is not the amount of matter or energy in existence, but the way they are arranged. Binding energy, the energy that holds a nucleus together, defines whether a configuration is stable or strained. When a reaction moves matter toward a state of lower overall energy, the difference is carried away as radiation or kinetic motion. Nothing is created, nothing is destroyed. The system simply settles into a configuration that demands less internal tension. This is why both fission and fusion can produce energy, despite appearing opposite in form. Heavy nuclei release energy when divided because their internal structure was inefficient. Light nuclei release energy when combined because their separation was inefficient. In both cases, the universe rewards arrangement, not magnitude. Power emerges from organization. The patience of stored energy is one of the most counterintuitive aspects of nuclear physics. A nucleus can carry enormous internal tension for billions of years without releasing it. Time alone does not force change. Only the right conditions do. Stability can persist indefinitely until a precise threshold is crossed. This reinforces a central principle. Potential does not demand expression. It does not decay simply because it exists. It waits for permission granted by structure, constraints, and alignment. When those conditions arrive, release is immediate and exact. Seen this way, nuclear physics is not a study of explosions, but of thresholds, of boundaries, of the narrow moments when rearrangement becomes possible. And once those moments pass, the system returns to quiet equilibrium, holding whatever energy remains just as patiently as before. The universe, it turns out, is not powered by constant output, but by stored possibility, revealed only when structure changes enough to allow it. Chapter 4. Fission. When holding together fails. When a heavy nucleus undergoes fission, the products are not arbitrary fragments. They fall into predictable ranges of mass and charge, favoring configurations that are easier to hold together. Neutrons are released not as byproducts of violence, but as necessary adjustments, carriers of imbalance leaving the system. The reaction proceeds because it leads toward a more stable distribution of forces. This is why fission can propagate. The released neutrons may be absorbed by nearby nuclei, pushing them past their own thresholds of stability. Yet even this chain reaction obeys limits. Without sufficient density, without precise conditions, the reaction fades. Power does not spread on its own. It requires structure, proximity, and timing. Control becomes the decisive factor. In a reactor, fission is slowed, moderated, and guided. Neutrons are absorbed selectively. Energy is drawn out gradually. The same process that can accelerate uncontrollably can also be held in steady balance. The physics does not change. Only the management does. What nuclear physics demonstrates here is not the danger of force, but the importance of boundaries. Instability is not inherently destructive. It becomes destructive only when it exceeds the system's ability to regulate it. Within limits, correction is productive. Beyond them, correction becomes collapse. Fission therefore represents a transition, not an end. A heavy nucleus does not disappear. It becomes something else, something better suited to endure. The system loses mass but gains stability. It releases energy but settles into order. Seen this way, fission is not a failure of strength. It is the resolution of excess. A system adjusting itself when balance can no longer be maintained, choosing stability over accumulation and precision over weight. Chapter 5. Fusion. The courage to withstand pressure. In fusion, the challenge is not merely bringing nuclei together, but holding them together long enough for the strong nuclear force to take over. At close range, this force overwhelms electromagnetic repulsion, binding nuclei into a new, more stable configuration. The energy released does not come from the pressure itself, but from the change in binding energy once fusion succeeds. Pressure is the gate, not the source. This is why fusion is so difficult to reproduce on Earth. Temperature, density, and confinement must be maintained simultaneously and continuously. A momentary success is not enough. The system must persist under extreme conditions without collapsing, dispersing, or destabilizing. Endurance is not incidental. It is the requirement. Stars achieve this not through control, but through scale and gravity. Their mass provides constant compression, creating an environment where fusion can proceed steadily for millions or billions of years. Balance emerges not from gentleness, but from sustained force applied without interruption. The star does not strain once and succeed. It holds pressure indefinitely. Fusion also reveals the narrowness of productive extremes. Too little pressure and nuclei never meet. Too much instability and the system tears itself apart. Productive fusion exists only within a precise window, where resistance is overcome without destroying the structure that applies it. Even the most powerful process in the universe is limited by balance. In this way, fusion completes the lesson begun by fission. Fission corrects excess by division. Fusion builds stability by union. Both move systems toward configurations that can endure longer than their predecessors. Both release energy not through violence, but through rearrangement. Fusion does not promise comfort. It promises continuity. Light exists because matter accepts conditions it cannot escape and holds them long enough for transformation to occur. The universe does not reward pressure alone. It rewards pressure that is sustained, contained, and aligned. And from that alignment, stars burn. Chapter 6. Control is the highest form of power. In a reactor, nothing is left to chance. Neutron speeds are moderated, reaction rates are monitored, heat is removed at a pace that preserves equilibrium. The goal is not maximum output, but sustained function. Power that cannot be maintained is not useful power. It is merely a transient event. This reveals a deeper distinction between force and capability. Force is easy to demonstrate. Capability is difficult to sustain. Anyone can trigger release. Few can manage continuity. Nuclear engineering exists not to prove how much energy can be produced, but how reliably it can be controlled over long periods of time. The same logic applies at every scale of physics. Systems that endure are those that regulate themselves. Feedback, limits, and correction are not constraints imposed from the outside. They are the mechanisms that make stability possible. Without them, complexity collapses under its own intensity. Restraint, then, is not a limitation placed on power. It is the framework that allows power to remain available. A reactor that runs safely for decades demonstrates more mastery than a reaction that burns brightly for seconds. Longevity is the true measure of control. Nuclear physics leaves us with a clear conclusion. The highest form of power is not explosive, but sustainable. It does not seek attention. It does not rush. It operates within narrow margins, corrected continuously, guided by understanding rather than impulse. In the end, the universe does not reward those who release everything at once. It rewards systems that know how to hold themselves together. Chapter 7. Chain reactions and consequences. In nuclear terms, this is known as criticality. Below a certain threshold, neutrons are lost faster than they are produced, and reactions fade. Above it, each event sustains the next. The difference between stability and runaway change is not magnitude but balance. A system does not need more force to transform, only the right conditions. This is what makes thresholds difficult to recognize. Nothing appears different until everything is. The system behaves normally right up until it cannot. Cause and effect separate in time. The initiating action may seem insignificant, while the outcome appears disproportionate. But physics makes it clear, the outcome was never sudden, it was prepared. Nuclear physics therefore trains attention toward accumulation rather than events. It teaches that what matters most is not the visible moment of change, but the invisible sequence that led there. Every neutron absorbed or lost alters the future state of the system. Nothing is neutral. Everything contributes. Once a chain reaction begins, reversal is no longer simple. Control must already be in place. Delayed intervention is often ineffective because the system is now responding to itself. Feedback has taken over. At this stage, outcomes are no longer chosen, they are executed. This is why mastery focuses on early conditions, on margins, on regulation long before intensity appears. The most important decisions are made when nothing seems urgent, when systems still appear calm. Nuclear physics does not dramatize transformation, it explains it, and in doing so it reveals a quiet truth. Lasting change is rarely triggered by force alone, but by small influences applied consistently until balance can no longer hold. Chapter 8. Why this feels uncomfortable. Nuclear physics feels uncomfortable because the human mind did not evolve to understand subatomic reality. Our intuition is built for survival at human scale, not for navigating forces that operate beyond direct experience. When the mind encounters these ideas, it resists. This resistance is not failure, it is adaptation. The brain is being asked to abandon shortcuts and rebuild its internal models of reality. Confusion is not a signal to stop, it is a signal that restructuring is taking place. Every moment of difficulty represents an expansion of understanding. Just as particles resist new configurations, the mind resists unfamiliar structures. With patience, clarity emerges. And with clarity comes a deeper form of stability. Understanding the quantum world requires embracing paradox. Particles can exist in multiple states at once. Energy can be both wave and particle. The mind trained to categorize and simplify struggles to accept this ambiguity. Yet in that struggle lies the path to intellectual growth. The discomfort is a mirror, reflecting the limits of current understanding and pointing to the edges where knowledge grows. Each concept learned, each principle internalized, is like adding a new dimension to perception. The mental muscles that struggle today become the strength of insight tomorrow. What once seemed impossible slowly becomes familiar. What once seemed chaotic begins to reveal patterns. In this process, doubt is not an enemy, but a companion. Confusion is not a barrier, but a doorway. The mind learns not only to accommodate new knowledge, but to transform itself, to think in ways that were previously unimaginable. This is the true beauty of studying the subatomic. It does not merely teach about the world, it teaches about the mind itself, its capacity for adaptation, and its potential to glimpse truths far beyond ordinary experience. Persistence is not about force, it is about resonance. By continuously engaging with complexity, by remaining present in uncertainty, the mind gradually attunes itself to the subtleties of nature. And just as the structure of matter is built from interactions that defy intuition, so too is understanding built from patience, effort, and the willingness to dwell in the strange until it becomes clear. Ultimately, nuclear physics is not just a study of particles. It is a meditation on the mind's power to expand, to confront the incomprehensible, and to emerge on the other side with a deeper sense of coherence, wonder, and intellectual courage. Chapter 9. You are learning how reality survives. Stars exist because balance is maintained between collapse and explosion. Too much pressure, and they collapse. Too little, and fusion stops. Life exists because nuclear reactions proceed at precisely controlled rates. The sun does not rush. It does not hesitate. It maintains equilibrium. Your existence is downstream of this balance. Every calorie of energy your body uses, every moment of warmth on your skin, traces back to controlled nuclear reactions occurring millions of kilometers away. This is not abstract knowledge, it is intimate. To study nuclear physics is to study the conditions that make existence possible. You are not observing something distant. You are learning the rules that allow you to be here at all. Every atom in your body carries the history of stars. Carbon, oxygen, nitrogen, the building blocks of life, were forged in stellar furnaces long before Earth even existed. The stars' patience, their steady rhythm of fusion and balance, flows through you. Your heartbeat, your metabolism, your very thoughts are echoes of cosmic precision. The universe operates on a scale that defies instinct, yet its patterns are not chaotic. There is purpose in the forces that guide matter, precision in the reactions that power life. When you study these reactions, you are not merely calculating numbers or observing phenomena. You are tracing the blueprint of existence itself. And there is a lesson here for the mind. Just as stars maintain balance between forces that could tear them apart, so too can the human mind find equilibrium amidst chaos. Understanding arises when you learn to sit with complexity, to witness tension without collapse, and to act with patience when immediate results are impossible. The forces that govern atoms are subtle, and yet they are consistent. So too can understanding become if you give yourself time to integrate, to absorb, and to expand. Every question you ask about nuclear physics is a step closer to recognizing your own connection to the cosmos. You are, in a literal sense, a child of the stars, carried by reactions that began billions of years ago. And in that recognition, wonder becomes knowledge, and knowledge becomes a profound gratitude for the balance that allows you not just to exist, but to witness existence itself. Final chapter. Control the reaction. Inside you exists energy, not explosive energy, but stored energy, attention, emotion, intention, thought. Like nuclear energy, it does not announce itself. It accumulates quietly, waiting for conditions to determine how it will be expressed. Left unmanaged, it disperses, spent in friction, distraction, reaction. Guided with care, it compounds, slowly, relentlessly, transformatively. Nuclear physics does not glorify force. It explains why force alone is never enough. It teaches that power without regulation destroys the very structure that produces it. The most enduring systems are not those that release everything at once, but those that maintain balance long enough for work to be done. This is not just a scientific principle. It is a human one. Your mind is a reactor. Your habits are control mechanisms. Your discipline is moderation. Your focus is containment. When attention is scattered, nothing sustains. When emotion is unregulated, intensity collapses into exhaustion. When ambition exceeds structure, progress becomes instability. But when limits are respected, when feedback is listened to, when correction is continuous, energy remains available. The atom does not rush. It does not improvise. It does not react emotionally. Its behavior is governed by invisible constraints that allow immense forces to exist without tearing reality apart. Chaos is avoided not through suppression, but through structure, not through fear, but through alignment. The same is true within you. Your thoughts can collide endlessly, generating heat but no light. Or they can be directed, allowed to interact under conditions that produce insight instead of noise. Your emotions can erupt and burn out, or they can be shaped into resolve, empathy, and sustained courage. The difference is not intensity, it is control. Control is often misunderstood as restriction. In reality, it is what makes freedom usable. A reactor that releases everything at once is not powerful, it is finished. A system that endures, that produces steadily over time, shapes worlds. Stars do not burn brightly because they are reckless. They shine because pressure is held, reactions are moderated, and balance is maintained across unimaginable spans of time. So it is with growth. Every choice you make is a neutron added or absorbed. Every habit alters the future state of the system. Every moment of restraint preserves energy for what matters. Nothing dramatic is required. Small corrections, applied consistently, determine outcomes far more than rare bursts of effort. Transformation is not sudden. It is prepared, built quietly moment by moment, long before results are visible. To study nuclear physics is to witness how reality survives its own power. To apply its lessons inwardly is to learn how you survive yours. Patience is not passivity. Restraint is not weakness. Limits are not enemies. They are the architecture that allows strength to persist. Energy is inevitable. Power is unavoidable. But control, true control, is rare. And it is there in that quiet mastery that lasting strength is born. Nuclear physics. Control the reaction. Life control yourself. Harness the silent force within. Let it work steadily. Let it endure. Nothing louder is required.